This week we are talking about functions. So function operations is the topic of today. Operations just means our addition, our subtraction, our multiplication, and our division. Functions, you guys have seen functions before. So these are usually written as f of x equals something. We're going to see them labeled in different ways because we're going to have more than one function. So we're going to have like an f of x, we might have a g of x, we might have an h of x, but it's all the same thing. It all represents a y value, but they're just for different functions, and it helps you differentiate between the different functions. We can't just label everything as y equals, because then we wouldn't be able to differentiate between things. So that's why we have function notation. So you can just have the different names for the different equations, basically. Okay, so first we're going to do addition. So this is actually pretty easy. You're really just going to do what it says. So right here, it says to add them together. If you see a variable right here, notice this variable is the same as the variables that are in the functions. So you can look at this like another way to write it is you're just finding f of x plus g of x. And you just are adding the two functions together. So my f of x is 3x plus 4. The g of x is negative x squared minus 3. And then from there, you're going to just combine like terms. You want to make sure that you put it in standard form when you do that, just to make it proper. So we put our negative x squared out front, plus 3x, and then we have two constants, our 4 and our negative 3, put those together, and we get a plus 1. So when you see a variable here, that means you're not like substituting anything in. Your answer is going to be just another function. It's a polynomial. If you go to this example, now this is asking us still to add our functions together, but we have a negative 9 here. So they want us to find f plus g, so add your functions together, of negative 9. So what that means is plug negative 9 in for x when you're all done. So f of x plus g of x. So we're going to take our negative x plus 4 minus 2x minus 5. And again, combine your like terms. So negative x, negative 2x, that's going to give me negative 3x. 4 minus 5 is negative 1. So this is f plus g of x. But they want us to find f plus g of negative 9. So what that means is we're just going to take the negative 9 and we're going to substitute it right here for this x. Negative 3 times negative 9 minus 1. This is going to give me a 27. 27 minus 1 is 26. Okay, so we get a number for an answer. So that's the difference. Whenever you're adding your functions together and then they tell you something to plug in, a number to plug in, then our answer is going to be a number. So if we look back at that first one, see, they didn't give us anything to plug in. So our answer is just a polynomial. Let's try a subtraction. So again, you're just following the directions that they're giving you. Find h minus g of n. And again, as you can see, the n is just saying, hey, that's the variable we're using. Don't change anything. Don't plug anything in. So you're going to just do h of n minus g of n. For the subtraction, you have to be careful because if your second function has more than one term, you always want to make sure you distribute that negative. So your h of n is 3n plus 5 minus, and then make sure you open a parenthesis so you don't forget to distribute, n squared plus 5n. And then you distribute your negative, and combine like terms. Okay, so see, I distributed my negative. That's how these signs are going to flip. Now combine our like terms and put it in standard form at the same time. So we have a negative n squared out front. 3n minus 5n is going to give me negative 2n. And then we have our plus 5. So we didn't have anything to plug in, so our answer is just another function, another equation. Now for this one, they do give us a number to plug in. So you want to take and subtract your functions. So take your h function, which is 2t minus 5, minus your g function, and your g function is t squared plus 3. Make sure you use those parentheses so you don't forget to distribute. Distribute your negative. And then from there, we're going to go ahead, combine like terms. And then they're telling us to plug in negative 1 for the variable. So we're going to replace the variable with a negative 1. So we have negative. We're replacing just the t, so negative 1. Plus 2 times negative 1 minus 8. Okay, so this power of 2 is only on this guy right here. So this is going to go positive. So this actually turns into negative 1 because this power of 2 does not affect this negative out front. So it's just going to change this negative 1 right here that I messed up. Negative 1. It's just going to change that negative 1 to a positive, but then this negative still is out front. And then 2 times negative 1 is negative 2 minus 8. So that's negative 11. So again, we had a number here, which means we're going to get a number for an answer. Multiplication. So when you see this tiny little dot, that's multiplication. So you're just going to multiply your functions. So it's just g of x times f of x. You have to be careful though, because you're taking the functions and multiplying them times each other. So it's negative 2x plus 4, use your parentheses, times 2x minus 1. So this actually becomes a FOIL when you do these. So if you don't use your parentheses, you might not see that. So you have to make sure you use your parentheses. It's a quantity times a quantity. And then we just go ahead and FOIL. So you're going to do your negative 2x times your positive 2x and get a 4x squared, negative 4x squared. Negative 2x times negative 1 is going to give me a positive 2x. 4 times 2x is 8x. And then 4 times negative 1 is negative 4. And then just combine your like terms. And again, we didn't have anything to plug in, so this is our answer. And then here's an example of one where we do have something to plug in. So find g times h of 1. So you're going to take your g function, which is 2a minus 4, and you're going to multiply it times your h function, which is a cubed minus 5a squared. Again, you need to FOIL. So 2a times a cubed is going to give me 2a to the 4th. 2a times negative 5a squared is going to give me negative 10a to the 3rd. Negative 4a times, or negative 4 times a cubed is negative 4a cubed. And then negative 4 times negative 5a squared is going to give me positive 20a squared. Combine your like terms. So we have negative 14a cubed okay, and then if this was just an a here, we would be done, but this is a 1. They're telling us to substitute. So you're going to add in that 1 for all the a's. So you're substituting. So that's 1 to the 4th. Okay, so anytime you raise 1 to any power, it just stays 1. So this just turns into 2 minus 14 plus 20. Okay, so we had an answer, sorry, we had for our original problem here, they asked us to find g times h of 1. So that means if you have a number here, we have a number as an answer. Okay, and then lastly, I want to just show you a division. The division problems, a lot of times when they ask you to just do, the function over itself and they're not asking you to substitute anything in, a lot of times there's nothing you can really do with it. You can just put the g function over the h function, and then that's your answer, because none of this is going to reduce. Even if I would factor this denominator, we still don't have any like quantities that we can cancel off or anything. So this just is your answer. You don't have to necessarily factor it. If you want, you can, but you don't have to. And then when we have the ones where they're asking us to substitute a number in, again, just put the functions over themselves, the functions over each other. So g on top, x plus 4, h on bottom, x squared minus 4x. But now for this one, they're asking us to plug a 7 in. So just plug in your 7. So the top becomes 7 plus 4, and the bottom becomes 7 squared minus 4 times 7. So then we get 11 on top. 7 squared is 49 minus 28. So we get 11 over 21, I believe. And if you could reduce that, then you would, but we can't, so we won't. So, okay, well, I'm attaching a worksheet for you guys to try a couple each of these, and then let me know if you have questions.